In this video, we're going to talk about how to simplify nth root. So we can also simplify nth roots of variables. What you're going to do, just like we did with square roots, is you're going to look at the exponent of the variable. If the exponent is not divisible by the index, then what you need to do is figure out the highest multiple of the index that can be taken out of the exponent. So for example, if we have 17, the largest multiple of 5 that's less than 17 is 15. Right? So the 17 we can rewrite as x to the 15 times x to the 2, because 15 plus 2 is equal to 17. So now we can use the product property of roots to separate this. So we have the fifth root of x to the 15th times the fifth root of x squared. So x to the 15th I can rewrite as x cubed to the fifth power because of the power property. If we have an exponent raised to another exponent, we multiply the exponents, and 3 times 5 gives us 15. So this fifth root and fifth power cancel each other out, so we have x cubed, and then we have the fifth root of x squared. So how do you know if a variable with an exponent has an nth root? Well, you're just going to look at the exponent and see if it's divisible by the index. So here we can take the fourth root of x to the 12th because 12 is divisible by 4. Okay, so that's how we get x cubed. If it's not divisible by the index, then you have to factor out the largest exponent that's divisible by the index. So for x to the 15th, I can't divide 15 by 4, but I can rewrite 15 as x to the 12th times x cubed. Then I can separate this into two radicals, and then I have, the fourth root of x to the 12th, which is going to be x cubed. So that's how I can use that to simplify. So remember, when you're taking the nth root of a variable with an exponent, you can do so by dividing the nth exponent by the index. So if we have the third root of x to the 36, we do 36 divided by 3, and that's how we get x to the 12th. If we have multiple variables, we do the same thing. So we just take 16 divided by 4, and we get x to the 4th. 8 divided by 4 gives us y squared. 12 divided by 4 gives us z cubed. Okay, and that's what I did back here too. So I did 12 divided by 4 and got x cubed. Here I did 12 divided by 4, and that's how I got x cubed. Okay, so let's put this all together, and so let's find the nth root of expressions. So remember, we're going to look at the coefficients and variables separately, just like we did with square roots. So for the coefficients, you're going to use the roots chart, and then figure out the biggest value that you can divide out, and then take the root of that number. For the variables, you're going to determine the highest multiple of the index that can be taken out of the exponent, and then find the nth root of that term. In the final step, we're going to reassemble all our terms and put the terms under the radical together and the terms on the outside together. So now let's try simplifying this expression. So I'm going to separate everything so we can use our strategies to solve. So we have the cube root of 125, the cube root of x to the 6th, and the cube root of y to the 4th. So the cube root of 125, if you look at your chart, you will notice that 125 is actually a perfect cube. So we can rewrite this. This is the cube root of 5 cubed, so that's just going to be 5. So the cube root of x to the 6th, 6 is divisible by 3, so we can just do 6 divided by 3, and we can get x squared. Well, if we look at the cube root of y to the 4th, 4 is not divisible by 3, so we'll rewrite this as the cube root of y cubed times the cube root of y to the 1st. 3 divided by 3 is 1, so I'm just going to turn that into y, and then I have the cube root of y. So let's reassemble everything. We have 5, and we have x squared, and we have y, and then we have the cube root of y. So that is now our fully simplified answer. So now let's try simplifying this expression. So we have the fourth root of 64 x to the 8th, y squared z to the 19th. So I'm going to separate everything. So we have the fourth root of 64, fourth root of x to the 8th, fourth root of y squared, and the fourth root of z to the 19th. So the fourth root of 64, I can rewrite that as the fourth root of 16 times the fourth root of 4. So what we can do now, the fourth root of 16, well, that is going to equal 2. And so we have 2 times the fourth root of 4. 8 is divisible by 4, so we can rewrite this as x squared. And then here, notice that we have an exponent that's less than our index. And whenever you have that situation, it's already in simplified form. So we're just going to leave it like that. 19 is not divisible by 4, so we need to simplify the z term. We're going to rewrite this as the fourth root of z to the 16th times the fourth root of z cubed. So 16 divided by 4 is 4, so we have z to the 4th times the fourth root of z cubed. So let's reassemble everything with all of our terms on the outside. So we have 2 and then x squared and then z to the 4th. And under the radical, we have the 4th root of 4, and we have our y squared, and we have z cubed. Okay, so this is our fully simplified expression. So now you can go ahead and pause the video and try doing this example on your own. So the cube root of 192, I rewrote that as the cube root of 64 times the cube root of 3. The cube root of 64 is 4, so I have 4 times the cube root of 3. The cube root of x to the 8th, well, I rewrote x to the 8th as x to the 6th times x squared. Cube root of x to the 6th is going to be x squared, because 6 divided by 3 is 2, and then we have the cube root of x squared. The cube root of y to the 9th, I do 9 divided by 3, and I get y cubed. All my terms on the outside are 4x squared y cubed, and then I have the cube root of 3x squared. So now let's try simplifying this expression. So notice what's different here is I have a negative radicand, but that's okay because my index is odd. So I'm going to rewrite this as the cube root of negative 40, and then the cube root of x to the 16th, and the cube root of y to the 21. So the cube root of negative 40 I can rewrite as the cube root of negative 8 times the cube root of 5. The cube root of negative 8 is negative 2, so I have negative 2 times the cube root of 5. X to the 16, well, 16 is not divisible by 3, so I'm going to rewrite this as the cube root of x to the 15th times the cube root of x to the 1. So 15 divided by 3 is 5, so I have x to the 5th times the cube root of x. And then 21 is divisible by 3, so I can just rewrite that as y to the 21 divided by 3, which is 7. So now let's reassemble everything. All my terms on the outside are negative 2, x to the 5th, y to the 7th, and then I have the cube root of 5x. So that is now my fully simplified expression. So now let's try another one. So here we have another negative radicand, but that is perfectly all right because my index is odd. So I have the 5th root of negative 288, the 5th root of x to the 12th, 5th root of y to the 5th, and the 5th root of z to the 20th. Okay, so the 5th root of negative 288, I can rewrite as the 5th root of negative 32 times the 5th root of 9. The 5th root of negative 32 is going to be negative 2, and then I have the 5th root of 9. 12 is not divisible by 5, so I'm going to rewrite this as the 5th root of x to the 10th times the 5th root of x squared. So 10 divided by 5 is 2, so I'm going to rewrite this as x squared times the 5th root of x squared. So the 5th root of y to the 5th, I do 5 divided by 5, so I get y to the 1. Well, I'm just going to write that as y. And then the 5th root of z to the 20th, 20 divided by 5 is 4, so that's going to be z to the 4th. So I'm going to gather all my terms on the outside. So I have negative 2x squared y, and then I have z to the 4th. And then I have under the 5th root, I have 9, and then I have x squared. So this is now my fully simplified expression. So now you can go ahead and pause the video and try doing this example on your own. So I once again separated everything. So I have the cube root of negative 8, the cube root of x to the 17th, and the cube root of y to the 13th. Cube root of negative 8 is negative 2. The cube root of x to the 17th I rewrote as the cube root of x to the 15th times the cube root of x squared. 15 divided by 3 is 5, so I get x to the 5th cube root of x squared. The 13 is not divisible by 3, so I rewrote this as the cube root of y to the 12th times the cube root of y to the 1st. 12 divided by 3 is 4, so I have y to the 4th cube root of y. I gathered all my terms on the outside, so I have negative 2 x to the 5th, y to the 4th, and then the cube root of x squared y. So now let's try this example. So I have a negative radicand, but here I have an index that is even, okay? When you have an even index, you cannot take the root of a negative radicand. So I would say this has no real solution. Okay, so be careful on that. You can only take the root of a negative radicand if you have an odd index. So now you can go ahead and try this example on your own. So in this case, I do have an odd index, so I can go ahead and separate out my coefficients and my variables. Cube root of negative 27 is negative 3. The cube root of x to the 6th, I do 6 divided by 3, which is 2. So you can find the nth root of an algebraic expression by looking at the coefficient and variables separately. Factor the largest power of n possible from each term and then take the nth root of these terms to simplify.